Today we are talking about scatter plots and their trend lines, which we also call lines of best fit, and also their correlations. So this section is going to be split up into two parts. You can do this section at home, and then we'll talk about how to actually make a line of best fit on the calculator in class. So let's talk about scatter plot relationships. We have three different kinds. The first is a positive correlation, which says that as the y values tend to increase, the x values tend to increase. So you can see it here if I draw a line. This is called a line of best fit that I just drew through the points because it's demonstrating like how the data is generally moving. As x increases, y increases. So this is a positive correlation. You can draw a line to represent the data. I kind of think of it as like this is like a river, and I'm using the line to represent how this river thing is moving. So it's going up and to the right. The other correlation is no correlation, which would be if there's no relation. Like I could try to draw a line through this, but honestly, I'm not really sure how to do it to make it accurate. And so this would be no correlation because there's not a clear up or down going on. And the last one is negative. And I can draw a clear negative line through these points because the points are generally going as x goes up. As x increases, the y values are decreasing. So what I just did in red, those red lines are actually called lines of best fit. We try to put the line with the data to make it demonstrate, like I said, how the data is moving, kind of like a river, showing how it's moving over time. And generally we have about the same amount of points on both sides of the line. So let's go ahead and talk about lines of best fit. And this is how you would do it if you do not have a calculator. I'll tell you in class how to do it with a calculator, which is pretty awesome, but you can do it like estimate a line of best fit without a calculator. So to do that, you'll make the scatter plot of the data and then decide whether the data can be modeled by a line. Usually, until we get to second semester, we're in our unit on linear functions. So as long as it looks like it's generally a line-ish kind of shape, then you can draw a line through it. So then draw a line that appears to fit the data closely. You about want as many points above the line as below it. So we're going to graph this table here, and I think this is kind of weird because water consumption is actually your x, and temperature is your y. So it's backwards. Sorry. So you just have to make sure you look at this column on the right for the x because that's how it has it labeled on the graph. Okay, so the water consumption at 48 ounces, the temperature is 99, so I go to 48, and then I follow it up to 99, right about there, and I graph my point. And if you want to like cross off as you go, that might be helpful. At 27, it's at 85, so right there. This is tricky. Okay. 48, it's at 97. So those points are really close together. At 16, it's at 75. So it'll be here, 16, 75. At 32, it's at 92. At 25, the temperature is so 25 would be about here. It's at 85. And at 20, it's at 83. Okay, so that's about as good as I'm going to get it. And we're going to make a line of best fit through this data. So that means that we are going to decide whether this data can be modeled like a line. Well, it generally looks like it's a liney kind of shape, a linear shape. We can draw a line through it to represent it. So I'm going to do that. And I want about as many points above the line as below it. So I think actually right now I need to move this right about, it's tricky. Maybe about there. I'm not quite sure. We wanted to model the data. So that seems about good. I've got about 3 points above, 4 points below. I could even move this to go more like through that point, but it doesn't have to go through any points. It just has to have the same amount of points above and below. So now we're going to choose from these equations which one is approximately the right one. Okay, this blue line, and I should give it an arrow because it does keep going. This blue line is a positive line because, as slope dude would say, it is puff, puff, positive. It is going up. So that means that these two right here that have negative slopes are not going to work. So we're going to cross those out. And now we're left with the ones that have a positive slope of 2/3. So now since they both have the same slope, let's look at our y-intercepts. This guy has a y-intercept of -50. This one is positive 68. It looks like the line I graphed right now has a y-intercept right here at about 75. Remember, my line is an approximation, so there's some error there. But it's definitely in the positives, and it's not going to be a negative. So that means that this line is not going to work, which leaves me with D as the correct answer because that's the only one that has a positive slope and a positive y-intercept. So we're approximating. The biggest thing I need you to be able to do is use and make an approximate line, and then use your best judgment to see, okay, approximately what's my slope and approximately what's my y-intercept, and then choose from a list of options. Okay, so now we're going to talk about correlation and causation. Correlation, if two variables are correlated, it just means that there's a connection between them, whether it be positive, negative, or none. And you guys saw that on the front. Those are the three relationships. Causation is when one variable produces change and the other, actually causes it. But the big thing I need you to get from this is that correlation does not necessarily imply causation, meaning just because two things have a relationship doesn't mean that they automatically cause one another. So our first example will show that. Let's look at this graph and answer the statements. So if you look at this graph, we've got sunglasses sold and ice cream sales. It looks like I can let's draw a line of best fit to make sure we see it. As sunglasses sold goes up, so do my ice cream sales. Okay. So it's pretty clear, as sunglasses go up, so do ice cream sales. This is to describe the correlation. The correlation has to be positive because it's a line that goes up. So anytime you're given a scatter plot and you're trying to figure out the correlation, I would draw a line. And that's because as sunglasses increase, so do the ice cream sales. All right. Does the graph illustrate causation? Okay, so is the increase in sunglass sales causing the ice cream sales to rise? Do we really think that when I sell more sunglasses, people buy more ice cream? Is that causing the other thing? No, because there are other reasons, right, why ice cream sales might go up, not necessarily because of sunglasses. Think of some outside factors. Like maybe it's hot outside, and so that's causing both of these to go up. So then the reason for the ice cream sales would actually be the heat outside and not this rise in sunglass sales. While those two are related, as one increases, so does the other. It's not because the ice cream sales aren't rising because sunglass sales are rising. So I'm going to say no because there are other factors like heat that could cause sales to rise. So no, because there's other factors like heat that could cause a rise in sales. So we're going to look at some more. It's possible that correlation can imply causation. It just doesn't happen every time like what you saw there. Another classic one is actually as murder rates go up, ice cream sales do as well. And that's like something that you can look it up if you don't believe me on the internet. But obviously, ice cream is not causing people to murder each other. It's probably, again, like the heat or being outside in the summer. So just because things are related doesn't mean that they cause one another. Let's do these ones. Analyze the situation, answer the questions. The age of a car and its resale price. Okay, as a car ages, if the age of the car is increasing, usually its resale price, as it gets older, it goes down. So is there a correlation? Yes. One goes up, one goes down. That means that it's going to be negative. Is it causing the other thing? Well, yeah, because as a car ages, that's going to cause the resale price to go down. That's like a pretty common thing that actually happens. So we do say that is causation. The points a student earns in a class in their final grade. Well, typically, as the points go up, so does the final grade. Is this correlation? Yes. They're both going up, so it's positive. Are the points causing the grade to rise? Well, duh, yes. If you get more points in a class, then you're going to get a higher grade. That is causing one another. Okay, a couple more. This one is kind of weird, all right. As fresh lemons imported to the United States from Mexico increases, the total highway fatality rate is going down. Are these correlated? Yes, they have a correlation. It appears that as lemons go up, fatalities, deaths on the highway go down. So that's negative. Is it causing one another? Do you really think the lemons are causing less deaths? No. Definitely not, right? It's probably just actually other factors like time. Maybe people are wearing their seatbelts more. As time goes on, you get more lemons imported and then more people wearing their seatbelt. Notice you actually have years here, 1997, 1998, 99, 2000. Probably more people are wearing their seatbelt. And then the last one, let's draw a line of best fit. Okay, so that's clearly a positive line. So does it have a correlation? Yes, it's positive. This is hours spent studying in the score in a final exam. Is there a causation? You can make an argument that there's not if you're like super convinced that if you're smart, you can just get a good score. But I'm going to say yes, because based on my research and my years of teaching, the more my students study, the more they do their review, the better they do on the test. So that's just my personal experience. Maybe you have a different experience. If you have like test anxiety, you could make an argument for no on this one if you feel like other factors could be at play.